Okay, this video is about finding empirical formula in simple questions where the percent mass is already given. So we're going to find the empirical formula. And just as a reminder, an empirical formula is the simplest possible formula, the simplest ratio formula of a compound. For example, if glucose is C6H12O6, this would be its molecular formula, okay? This is how the molecule actually looks, which means that 6 carbons and 12 hydrogens and 6 oxygens are bonded together in one molecule. The empirical formula would be the simplest ratio, that would be CH2O. And that's your example right here. So now let's look at a question. There's a compound called allicin. What its name is not really important to this question, but I'm going to write it regardless. And the percents as given in this question are carbon 44.4%, and then we have hydrogen, oxygen, and sulfur. Now hydrogen is 6.21%, oxygen is 9.86%, and sulfur is 39.5%. It's important to know that anytime you see the word percent mentioned, it's always percent mass, which means that in 100 grams of the compound, you're going to have 44.4 grams of carbon and so on. So right now, the one thing that you can immediately do in an empirical formula question is replace the percents with grams, because a lot of times you're just going to pretend there are 100 grams of the compound, which means that you have so many grams of each of these substances, okay? Remember that in chemistry, most often you can do nothing with grams. So we're going to create a column here for moles. And at this point, you should feel pretty comfortable going from grams to moles, okay? To go from grams to moles, you divide by the molar mass. The molar mass of carbon is 12, so you're going to divide by 12. You're going to divide by 1. I'm approximating right here. Your periodic table will have the exact values. So these are the molar masses of these individual elements, 12, 1, 16, and 32. And dividing by these numbers is going to give you the moles of each of the substances or each of the elements right here. And those are going to be... Okay, so right here in green, you have the number of moles of each of these substances. This is really the ratio that you're looking for. But right now, that's not enough. Obviously, you can't write C3.7, H6.21. So you take all of these numbers right here and divide by the smallest number that you have. As far as I can see, the smallest number in moles appears to be that of oxygen. So let's divide every number by 0.62 and get what looks like might be the simplest ratio. Already we know 0.62 by 0.62 is 1. And it looks like 6.2 by 0.62 is 10. So we know two of those numbers already. And the other numbers are 6 and 2 respectively, okay? So remember that you might get decimals, you might get numbers like 5.98 or 1.98 or 2.02. You are going to round them. So empirical formula is a little bit of an approximate thing going on here, okay? So here, right now, you have the empirical formula. So we have C6, H10, O, and S2, okay? This O1, S2, you don't have to write the 1. This is the empirical formula of the compound. Note that this is not the molecular formula of the compound, okay? The molecular formula of the compound is going to be this number times some integer n, okay? Now, what if I said that the molar mass of the compound, suppose the question told you that the molar mass of the compound was 162 grams. You would calculate the empirical formula mass. So you'd add 6 carbons, 10 hydrogens, 1 oxygen, and 2 sulfurs. And if you added all of them, you'd actually find that the empirical formula mass is also 162 grams. Since the molar mass is also 162 grams, the empirical formula is actually the same as the molecular formula, okay? If the molar mass would have been, let's say, 324 grams, then you would have had to double it. In that case, the formula would have been C12, H20, O2, S4. I hope that makes sense. What the actual formula is depends on what your empirical formula is and what the molar mass is. So you're going to do molar mass divided by empirical formula mass is your multiplying ratio. So we'll end with this little equation or formula right here, is that the molar mass, which should be given to you in the problem, divided by the empirical formula mass, which is the mass of the empirical formula you created. So we're just going to write divided by empirical formula mass is really equal to the multiplying factor n. N is the number that you multiply the empirical formula by to get your molecular formula. And that's the end of this section.